Winning in a battle of gravitation, intelligent people discover that an object heavier than the air can fly, but there's some condition which has to be respected. Now I want to talk about Brachma Controller, which is there's a lot of similarity in its function with the Honeywell controller, and it's slightly different to one point, and I'll explain to you where. But this one works in a similar way. The only problem, both valves are open in the same time. Honeywell controller can use a pilot flame. This one, you just open two valves in the same time. I will explain to you about this later on, but as far as you're concerned, what you have to make sure, you have the power supply into it, then the thermostat. So power supply is 1, 2, and then you have the thermostat between 3 and 7. You press a reset switch if someone worked before you to make sure he didn't left the system on fault mode. When you'll close the circuit, the fan will start, and then the differential pressure switch will close the circuit, and then you have the ignition, and then the valve will open and you'll heat up the store. So you will see in detail how the Brahma controller works. Before you replace the Brahma controller, I suggest that you will check if the Brahma controller it is reset. And also you can, if you want to go one step further, you can check, as I do sometime, if there's any soldering bits faulty, and also if you have the appropriate fuse. It's missing the fuse because this is a broken part, and I will just repairing and then I will test it. This is it. We'll speak today about Brahma controller, and if you will watch some of my videos, you will find a lot about all these little things that gives us headache on the field. I'm not a guru which sits in office. I'm an engineer which is always outside on the field in the rain and everywhere, and I'm doing my own investigations, and I'm paying for my courses, and I do the best to help my colleagues to understand better the HVAC industry. So if you subscribe to my YouTube, you will find a lot of information, and every time I will put something new, you will get access to all these free tutorials which comes from the real world. Thank you very much. Brachma controller, it is a type DM32. I'm using it for Resna burner, and it works with G44 PC board control sometime, or any other controller, it doesn't matter. Because I didn't learn this control like a poetry. We live in a world where a technician comes and replace half of your boiler, and it doesn't understand how electronics works. So instead to pay 5p for something, obviously plus his working fee, you have to pay a lot of money for these controllers, and this is something that I disagree, because we live in a consumption society, yet we have to respect our customers and to do the best to save their money in a real terms, not in a political terms, because political terms is easy. This Brahma controller will control the gas valves and will enable the gas valves if the system is healthy, and then it will heat your home. However, to say that you need lives in neutral will be a little bit inappropriate. This system needs a power supply like any other power supply, but the power supply should be controlled through a lot of safety features. But this tutorial, it is only about Brahma controller, how the Brahma controller works, and it does not involve the further control which will supply power to the Brahma control and will control its function through thermostat, etc. I will explain to you strict how the Brahma controller works. First, for the Brahma controller to work, we have to make sure that we have here fuse, and as you will see, this one doesn't have the fuse, but we all know that we have to have a fuse here, the appropriate fuse. I might try to towards the end of this tutorial to find the Brahma controller which might have a fuse, so you'll see how it looks like. First, we have to have a power supply right here. It can go through a switch, and also we have to have the neutral. So if you have a problem, as an example, where you know that you push a switch in your heater and the thermostat will ask the system to run, you have to check the following. First, in between 1 and 2, you have to see if you have live and neutral. That will be 240 volts, so if you use a multimeter, it will be easy for you to find out if you're a professional engineer and you know what to do. Once you have the power supply, you have to check if you have a heating demand. As you see, in between number 3 and number 7, you have a little switch. This is the thermostat. The thermostat on heat demand should close this circuit. It should be a short circuit between 3 and 7. I don't say you have to loop it. I just want you to check if your thermostat is closing the circuit between 7 and 3. You can loop this one only if you're a professional engineer while you're testing the Brachma, but you have to be there. You loop that thing and then you'll have a heat demand. Otherwise, the system will run continuously because there will be nothing to turn it off if the premises reaches the temperature. So this is the thermostat. Good. Once you have a heat demand in the power supply, you have to check the first. The fan should run. If the fan is not running, which is number 10 and 11, so this is the third check you have to say. If you have the power supply in between 12 and 11, so 12 and 11 will supply power to the flue fan. If the flue fan runs, then you have to check the proven switch or differential pressure switch, how you want to call it, and between 9 and 10, the circuit should be open before the fan runs. When the fan runs, the differential pressure switch, it's activated by the air generated by the flue fan, and the pressure created through some tubes will activate the differential pressure switch, and this switch will close, creating a short circuit between 9 and 10. If this is happening, it's always successful. The spark plug will start to generate a little spark, and the gas valves will open. So both gas valves open. When they open, the ionization probes will check if we have flame, because you will send the signal back into this controller, and the half rectified wave that comes back into this controller will be converted in different kind of signal, which will allow this will keep the flame latched until the flame will keep the valve open, will be latched as long as the flame will provide this half rectified waves into the ionization probe. So as long as you have a good flame, the system should work. If you have a good flame and the system cuts every 1 minute, 3 seconds, whatever, you might have to check the ionization probes, because this is a special alloy and the oxidation and the corrosion change his chemical structure, and you might be surprised if you look on an oscilloscope to see for yourself that things will change dramatically. This is a maintenance, this is a consumable, so the ionization probe must be changed. Sometimes people are changing the spark plug. Spark plug is not necessarily to be changed, because unless you don't have the nice blue sparks, will initiate the flame. And this is all about this. So if you have an issue with this Brachma controller, with a burner controller, you have to check, as I said. First, you have power at number 1, you have live and neutral at number 2. Then you have to see if you have a short circuit between number 3 and number 7, which is the thermostat, which closes the circuit. Number 5, in our case here, it is a reset switch. And the reset switch, you have to reset the system. You have to use a momentary push button to make a short between number 5 and number 6. You can use a little jump wire just to touch it, and that's it, it will reset itself. Because with many occasions I found faulty switches, and they do not create this short circuit because they corroded, and then you will press that a lot and the system will not reset. But this is up to you how deep you want to go in an investigation and to save your money, because this is an expensive little controller, and again, in 99% of the cases the controller is alright, so I end up with a lot of controllers. Yes, this is all about, you have to understand, you have the power supply, you have a short circuit, you reset it sometime to make sure you start from zero, the fan should run, the differential pressure switch should close the circuit to make a short circuit between 9 and 10, then the spark plug will start to have that blue flame because it will be initiated, then the valve will open and the ionization probes will read the information and will send it back to keep the valve latched, so the flame will run continuously until obviously the thermostat will interrupt the cycle. If the ionization probe does not read the flame correctly because you have a bad flame and you have to adjust the gas valves, whatever, or if the ionization probes it is corroded, or even the wire which connects the ionization probes to the machine's body, it is corroded, you might have the surprise that the flame will go in a couple of seconds out. That's all I have to tell you about this. I hope you understood. I'm Mihai John, and please look for more tutorials in my videos. I do this for free, and I want from the deep of my heart that our technicians understand 100% how things work, so they will not turn to the job 1 million times for no reason. Thank you very much. I'm living in a world where people want the first fix, but the accountants, they're not even engineers. They don't know what implies a first fix on a heating system that is controlled by a building management control. And to overcome this, I did a lot of videos to help you guys to understand how this electronic works and what do you have to be prepared to have with yourself sometime when you attend